So we'll do the skeletal structures first in the hoof, starting up here at the what people mostly call the knee, which is a misnomer because this is clearly the same as our wrist joint. It's the carpal joint, and so this is the whole thing is the carpus. These are carpal bones, and then that's going to have an articulation or a joint with this metacarpal, which is the hand. So this is the hand bone of the horse, and its nickname is the cannon bone, and so most people refer to it as the cannon bone. And a lot of times in animals like thoroughbreds, these things get real, we breed them to have as thin of cannon bones as they can possibly have because it makes them lighter, but then they're not structurally strong enough, and we tend to get breaks in them. So a real common place to break the cannon bone is right here next to this. This is actually where the epiphyseal plate would have been, and so where the joint would have been remodeling, or it's actually a joint, but where the bone would have been growing right here, this is kind of a weak spot, and so that's a common place to break it. And then where this epiphyseal plate would have been is another common place. Fetlock joint, and then pastern joint, and so this is basically essentially the finger of the horse right here. So these three bones are the same as I think it's actually this finger, this bone, and this bone. So this would be proximal phalanx, middle phalanx, and distal phalanx. These all fortunately have multiple names. Yay. Okay. So P1, P2, P3. That's pretty easy to remember on here because they're labeled 1, 2, and 3. So that's good. And then also we call this bone down here the coffin bone, and that's what we'll talk about a little bit when we get to laminitis. And then one more bone that you can see is this one. This is the distal sesamoid bone is its proper name, and it's referenced as the navicular bone. And so I'll show you kind of what that looks like, because you see it on this one and it's sideways, and so it doesn't quite look like the actual structure of the navicular bone, but this is the whole distal sesamoid. And so this deep digital flexor tendon is going to come down and go right over these two grooves like this, and then it's going to spread out and attach to the surface of the coffin bone, the distal surface of that right here. And that, when the deep digital flexor tendon then pulls back on the coffin bone, and this would be the deep digital flexor tendon, this yellow line, so you can see it's attached right there. So when it pulls back on this coffin bone, it's going to cause this joint to rotate, the pastern joint, and the fetlock joint as well. It's going to rotate the foot back like this. Now this joint here, this is the coffin joint, and I'm sure it has another name, distal phalangeal joint or something like that, but we just call it the coffin joint. I've heard people say this joint is fused. It's not fused. It could articulate, but it can't articulate because of the way the ligaments are actually wrapped around it. And so it is an articulatable joint, but it's a non-articulating joint, if that makes sense. And so it's actually tied so that it doesn't articulate. This one does, and this one does. Okay, what else do we need to look at? This is the hoof wall. It's related to your fingernail. It's got the same keratin structure, except a lot more keratin than what we have in our fingernails. And that's what makes it hard, like this. So it's mostly made of the protein keratin. And you can see that it's got really a couple of parts. So right up here where the coffin bone or the distal phalanx attaches to the hoof wall, this is basically going to attach to these laminae, and they look sort of like this. Okay, so they're interdigitating like that, and basically that holds these two together. So remember a second ago I said this deep digital flexor tendon pulls on the coffin bone and pulls it that direction? Well, what attaches that to the hoof wall are these laminae right here. And so if we see laminitis, or inflammation by definition of the laminae, it's going to be right in these connective structures between this hard bone and this hard hoof wall. And that inflammation causes swelling, and when you swell in that area, it can no longer get blood being squirted kind of up and down through these laminae. And so we sort of push blood down into the laminae here with this coronary band, and we sort of push it back up by compressing this digital cushion here. And so essentially what begins to happen is as the blood flow is blocked, as the flow of nutrients are blocked, then this will become necrotic or start to die. And the coffin bone becomes unattached to the hoof wall, And then when the horse continues to pull on this deep digital flexor tendon and keeps pulling on the coffin bone back like this, it will actually come apart here, and the coffin bone can rotate and actually begin to go sort of in this direction like this, and then can penetrate the sole of the hoof. And at the point where it penetrates the sole of the hoof, this animal is going to be shot. I don't really know how else to say it. It's not going to recover, basically. It's not going to be able to withstand that amount of pain. And most likely, if it gets to that point, both front feet, it's going to be favoring this one so much that both front feet are going to have laminitis. And it's probably not going to make it. So those are the basic structures of the foot. So cannon bone, just remember cannon and coffin sort of look alike when you read the two. So cannon bone is here. Coffin bone, it gets its name because if it rotates and pokes through the sole of the foot, you're pretty much left with looking for a coffin for the horse. And the other thing I would tell you is this distal sesamoid bone. One of the main jobs of sesamoid bones anywhere at any joint is partly to provide protection of the joint, but also to route this tendon. See how it sort of forces the tendon to bulge out like that? Well, what it's doing is it's routing that tendon so that you get the best mechanical advantage. So the forearm muscles up here are pulling on this tendon, and that gives it the best mechanical advantage. If it came straight down, it would just be pulling the whole foot back up. And so in this case, it causes it to rotate and to rotate the joint like that. Okay, that's about all I can think of to talk about. Anything else? Any questions? Good. All right.